Ooh, brain cracker.
Yeah, it is. This one is similar to the one we did before, index of, in the previous video. So we're going to take an array and we're going to kind of ask what the last position of a certain value is in that array. So if we give 2, 2 appears twice in this array on screen, but the last position is the one that we want to return. Did I say that right?
Yeah.
Okay, great. So 0, 1, 2, 3. And the answer should be 3. All right, let's take the challenge. So would you like me to put up the index of that we had from before? We can like reference it maybe?
I think it's quite similar. Yeah.
Yeah, let's do that. So if anyone's interested, we're not cheating. This is in a previous video. We just solved this index of, and we're going to maybe make use of it. We'll see. Where would you start with something like this?
Well, it's similar. We should only not return count on 47, but go on, and then then you have this greater than operator. Can we use that also?
To check.
Always greater than. Oh, okay.
No, like so the values here are lots of different things. The example was just numbers, but it can be any TypeScript value.
Yeah.
Can we iterate over the array in reverse order in some way?
Can we iterate? Say it again.
Over the array, but start at the end and go to the beginning.
Like this.
Yeah.
So this would be sort of like, this is really kind of wrong, but it would be something like this. Like we're going backwards through the array.
Oh, right.
Yeah, maybe.
Did you know that was possible? Because it's not possible with JavaScript.
Oh yeah, yeah. No, it's definitely possible in TypeScript to grab the last value. I mean, let's check that. Type test equals let's do t extends infer. It's going to be ... infer a, infer b, and then b a. So then we can say type x equals test, and then 1, 2, 3. Test, not text. So this is what I do when I don't know an answer to a question like that. Like how exactly does it work? What's the behavior? Infer b will give us the value at the end.
Cool.
We could switch this to see what the value of a is. Actually, a is not accessible here, which is why I was complaining. And then a is 1, 2. Yeah. Cool.
Okay. Well, then this should work, right?
It should. Let's see what's going on.
No, then we have because we
have to change this. Or what do you think we should do?
I think it's not gonna work because we don't know. We need to have the length.
There you go.
Accumulated in count, right?
Right. So it turns out that we don't need it, right? Because we're always checking. I guess it would be tail in this case. I got to rename these. Let's rename these A, B, and then we can go head, tail. Okay. So it turns out we don't need the counter, right? Because we're always going backwards.
Yeah.
So we don't need the counter at all. And we made a mistake, which is that we're working on index of, but actually LastIndexOf is what we're supposed to be solving. So it works.
Wow.
Yeah, that's it. I mean, it kind of makes sense when you go from what we had. I'm kind of glad we went from what we had before to what we have now, because we don't need to make use of a counter because we're not going forward. We're just taking things off from the back.
We were taking the length of head. Now I get it.
Get it? So the length of head is the thing that we're using as the counter. The length of the input itself.
Yeah.
Is the counter.
That's nice. Yeah.
So because
It's
there's
just-
this position here where we return it literally, and it works.
Wow. Cool. That's smart.